Thank you, Ben, for your introduction. So today I'm going to talk about how to run RStudio servers on, using containers. This is not meant to be a tutorial in 20 minutes, but I want to show you the reasons why we are exploring the container solutions on, to do data analysis and what has worked for us. So I lead the bioinformatics team at Innova Translational Medicine Institute. So, I'm going to tell you a little bit about what we do, and then I'm going to move on to why RStudio Server is useful for us, and what other limitations that we have found. And then I'm going to talk about two container solutions, namely Docker and Singularity, and then I'm going to show you how to run RStudio Server on these containers. So bioinformatics is a very broad term. It basically covers all the data analysis using biological data. And at ITMI, we mostly focus on trio-based whole genome studies. So this is, we look at both the parents and the child and together, because at the Innova Health System, there's 20,000 babies born every year in our health system, and of that, 10,000 babies were born in the Innova Fairfax Hospital. And so far, we have sequenced over 8,000 whole genome sequences, and at a very high coverage. And that's integrated with clinical electronic health record from the hospital, and also survey data that's been sent out every 6 months to our participants. And we also collect other omics data from the mother, like RNA-seq, microRNA-seq, and methylation. So R has been very popular in the bioinformatics community, mostly due to the Bioconductor project. And this is a screenshot from 2 days ago on the Bioconductor webpage. And it's hosting over 1,600 different softwares covering different areas in bioinformatics. And in my team, R is our default language to go to for data analysis. And we have been using RStudio Server hosted on our shared computing environment, our SGI cluster, for doing data analysis. So RStudio Server is great. So I'm sure most of you are familiar with RStudio. And RStudio Server provides a web browser-based interface to the RStudio. And that basically enables Chromebook data science, meaning that you only have to have a laptop with a web browser and a fast internet connection. And all your computing resource can be hosted remotely. And also all your data is also hosted remotely. So that really facilitates a lot of the data analysis, especially in bioinformatics when the data is huge. So there are a few limitations of RStudio Server running on the shared computing environment that we found. So first, you have to convince your system administrator to install and start the RStudio Server. And they would complain that there might be a security issue or performance issue that they may not want to do this. So after that, we have the same problem. After that, if you want to change the version of the R points to, you have to back your system administrator again. Some of the R package only runs on certain R version, and if it's hosted on a common computing environment, it's hard for him to change it without affecting other users. And each machine can only have one server running, meaning that you can only run one version of R. Also, if it's in a shared environment, if somebody is running a very computational intensive job, it's going to affect other users. So that's why we started looking at container solutions to see if this helps the problem. So I'm sure most of you are familiar with containers and virtual machines. So there are some fundamental differences between containers and virtual machines. So for containers, it virtualizes the underlying operating system, but virtual machine is trying to virtualize the underlying hardware. And for containers, it's sharing the kernel of the host OS to access the hardware, where the virtual machine uses hypervisor to manage and share the host hardware. And there's a lot of advantage of using containers. First, it's much more lightweight than a virtual machine, and it also provides this consistent environment and platform independence that virtual machine has. And it also provides cost saving on resources. You can run multiple containers on the same computing resource. So Docker is the most popular container out there, and there's a very well-maintained Docker repository on GitHub called Docker that provides Docker files for different Docker containers that are of interest to our users. So the base image is just R, and then the RStudio image adds RStudio to the base R image, and then tidyverse adds tidyverse and DevTools to the RStudio image. This is usually the starting point that I use when I want to use Docker, and I add my own packages and tools to this image. And Singularity started only 3 years ago, but it's been gaining a lot of popularity in the high-performance computing community. And one of the biggest advantages is that you don't need root-owned daemon process. So once you convince your system administrator to install Singularity, you don't have to ask him to do anything else. You can install you can install everything you want on it, and you can run it as a normal user. You don't have to be root. You don't have to have the root privilege. So to me, this is a huge advantage. And there are a lot of similarities between Docker and Singularity because they are both containers, but there are also differences due to the target user space that they are trying to focus on. So Docker is trying to have isolation. So basically, the containers are independent of each other. They cannot see each other, and if one container gets hacked, it won't affect the others. And the user inside the container cannot see the host process. And Singularity, because it's running on a HPC environment, it's focused on integration. So the user is the same user inside the container as outside. So for me, Singularity, you can run a Singularity image as if you are just running a binary on the host system. And for Docker, the images are as layers. So basically, they're just between this image and the parent image. Singularity, the whole thing is one single binary file, which means that portability is much easier. So you can basically copy the Singularity image to a different machine and use it there. Instead of like Docker, you have to commit and push it to the Docker hub before you can share it with a different computer. And as I mentioned, that the Docker image, the Docker container need to be start with privileged access, where Singularity you can start with just like a normal user. So I'm going to talk about how to run RStudio server on these containers. So to do this, first you need to pull the image or build the image. This is the same for whether you're going to run it locally or remotely. So for Docker, you can just pull it from the Docker hub. So you just do Docker pull of the image name, and you get the Docker image, and then you can run it. For Singularity, you can also pull it from the same Docker hub to get the Singularity image, or you can pull from the Singularity hub if it's hosted there. And also, you can build your own Singularity image using the Singularity definition file. In this case, you do have to have you do have to have the root privilege to do this. But there are two other solutions to do that. You can you can also use a VM that you can be root to build the image, and since it's a one file, you can copy it out and use it on the whole system that you're interested in running it on. Or the Scilabs, which is the commercial backend for the new Singularity, now created a Singularity cloud. So that allows you to build it remotely, and they will push the image back to you. All you have to do is put -- remote after the build. So why do we want to run RStudio server on HPC? And as I mentioned, that there's competing. If multiple users are running RStudio on the same RStudio server, they might be competing the computing resource. Using different, if we run it on a container and we obtain the right amount of resource for each container, then the resources are better managed. And also, sometimes you do have to use different version of R, and this can be done easily with a job scheduler. So this is a very simple example on how you do this on a cluster. So my script only has 2 lines. The first line is to just load the module so that the Singularity binary is in your path. And then you start a Singularity instance. And you give it the Singularity image file name, which is, in this case is rstudio.zip. And then it tells the machine that I want to call this instance RS. And the nice thing about Singularity is you can bind any folder or files to inside the container. In this case, I'm binding my rserver.conf.8790 in my host system to the rserver conf inside the container, which means that the container is going to use the rserver my own conf as the configuration file in RStudio. And in my own rserver conf file, there's only 1 line, and this is to change the default port of 8787 to 8790. You can add other options as well. And then you do a QSub like you normally do when you submit the job to the cluster, and then now you get RStudio server running. And then, so you can, if you know the host IP, then you can type in the IP with the port, and then you get the normal login for RStudio. Or you can, the better way to do this is use SSH tunnel with port forwarding so that the data is more secure. And now you can access the RStudio server normally and then you know that you're getting the computing resource that you need. And to run RStudio server on the cloud, you can use AWS. You can do it the same way like I showed before, using the same script. I'm showing you here how you can do this with Google Cloud Shell, which is free. But there's limitations on Google Cloud Shell is that they only give you 5 gig of persistent storage, and it's very limited in computing resource. But it's free, and if you want to just test out a R package, this is a nice way to do this. And so you start RStudio, you start Google Cloud Shell, and then you pull the Docker image. So in this case, I'm pulling the Docker RStudio image, and then I start a container by doing Docker run. And here I'm changing the default port from 8787 to 8080 because that's what the Google Cloud Shell web preview uses. And then I'm changing the password and the username, and then I also give the name of the Docker image that I want to use. And then you click on the web preview button, and then you get to this page, and you can log in and then use RStudio, and you can install your software and play with it. And to run RStudio locally, you don't have to use RStudio server or containers because you basically have all the rights to install anything. But I would still recommend using a container solution for reproducibility purposes because like you may submit a paper and in 6 months they may come back and you have to run the analysis. At that point you might have upgraded your R and a few packages and it will be a nightmare to reinstall to recreate the environment that you created. And for Singularity, you can just save the image and then you can start your RStudio server with that image and you get the exact same environment as before. And for Docker, what you can do is when you are using it, you can commit your changes and then you push it to Docker Hub and then you pull it down when you need it and you will still get the same environment. So I want to end this with a few tips and lessons that we learned throughout this process. For reproducibility, containers do give you some reproducibility, but be aware that the image, the definition file from Singularity or the Docker file does not give you reproducibility because you might be pulling the latest version of a software that may not be the same as what you have been using. So, so make sure, if you do this, make sure the tag info is included so it's pulling the right version. But the better way to do this is you keep the same image rather than keeping the definition file. And for security, as I mentioned, the user doesn't have to have root privilege to run Singularity containers. So it's just really much easier to convince your system administrator to install Singularity. Usually they would not install Docker on a shared computing environment because they don't want to give you root access. For debugging purpose, sometimes the RStudio server does crash, and then you lose all the information and there's no way to keep track of what caused this. So what I would recommend is you bind your log directory of the RStudio server within the container to your host system so that in case it crashes, you can still see the log files in your host system. And this is meant to be a feature of Singularity that by default, Singularity shares the home directory with the host system. But in a lot of cases, your RStudio .r profile is there and might be pointing to a different R version or have some settings that are not compatible with your with the RStudio that you're running on the container. So you should be aware of that and disable this option. And the same for environmental variables, that Singularity also share the host environmental variables, so be aware of that. And also to create images, I find it easier to create a Docker image and then bootstrap it from it to create Singularity images, just because there are so many more Docker images out there that I can use, but this may be changing in the future. So with that, I look forward to hearing your feedbacks and comments. My email is here, and I give you a few resources. And thank you, Ben and Kelly, for inviting me, and thank you for your attention.